I'm not gonna lie. And we are live, accordingly to YouTube, once again. And today, but first of all, let me notify the world that we are online, like usual. So I'm gonna tweet it, and then I'm going to my Discord channel. A little announcement, just like that. All right. How is your day? What is up? How it's going? Mine is fine. Mine is fine. So today, and my hands are still cold, I'm not gonna lie. It's getting cold here in this small little country called Belgium. So today, we're actually gonna continue with our JSON RPC stuff. Yesterday's stream, we created our RPC server, JSON RPC server, so we can interact with our blockchain. We can retrieve blocks by height and by hash. We can retrieve transactions by hash. But I think it would be super nice. Hi, UK Jared. Welcome once again to the army of the high-value engineers. I thought it would be nice so we can send transactions to our chain, right? So we create a transaction and then we send it to one of our nodes, and that node will validate it. It will put it into the mempool. The validator will put it into a block. It will broadcast and everybody will be updated. That would be nice. That would be our mission of mercy for today. So I need to warm up a little bit, I'm not gonna lie. Okay, so let's first of all start this thing, make run and see. Postman. So we did something like block, right? And let's say block 1. All right, that's working fine. I'm actually exhausted. I don't know why. So we have this hash. Yeah. We have one transaction. That's good. All fine. So what I was thinking is that we do something like, where is our server? Server. Is it API? Yes, it's API. And let me first quickly check commands. Well, Nightbot is sleeping, but it's okay. Oh, there he is. Okay, cool. Never mind. Just testing things out, right? Testing things out. Okay, so what I was thinking, we're gonna make a new endpoint. It's gonna be a post actually. Post to TX, I guess. And we're gonna say server handle. Maybe we should do post TX actually, like this. So we're gonna make this function server handle post TX. It's gonna get an echo context, and of course it will return an error. I'm gonna return null for now. Post TX. So let's open up TX real quick. Transaction. So we have data, which is any arbitrary data in order, basically code, bytecode for our VM. Oh, this coffee, delicious. We have the crypto public key. We have a signature, we have a hash. But this is a cached version, so we don't care about that. So what we're gonna do is we're gonna unmarshal this with GOP encoding for now. The question is, I think we should do something like Not sure if it's gonna work. So we're gonna say TX is going to be a core transaction. I'm gonna make it a pointer. Then we're gonna say if error gop decoder and actually I think we can do this. If there is an error, takes decode. This is gonna work. Not quite sure. Let me see. Let us try first with the GOP encoding because I have no clue what I'm doing, to be honest. So we're gonna say, what does it take actually? No definitions. RPC. Let me quickly cheat. I'm getting cold. The flu. Decoding. Encoding. It takes in a reader, right? The question is, it's a read closer. Does it work? Yes, it is. Now we're gonna say decode rather. Decode this TX. And if the error is not null, what's this? We're gonna return the error. No, we're gonna return a JSON thing. We're gonna return JSON. What is going on here? Okay, cool. So an API error, bad request, that's all fine. That's all Gucci. And actually we could print out verbose new line, TX, right? And we return null. It doesn't matter. Let's see if this is gonna work. Actually, let's go to main. So now we need to make a transaction and we already have this TX sender, transaction sender. Are we gonna reuse this actually? So we're gonna say, do we need to dial? We don't. We are not gonna write to the connection. We are not gonna make a message. So we are basically encoding this transaction into a buffer. That's good. So we could say something like, this is at the top of my head, so I have no clue if this is correct. The request is going to be HTTP, a new request. And what does it take? No definition. Why is it not working? HTTP, new request. Let me quickly check if the YouTube stream is going well, because YouTube, man, sometimes YouTube does nasty things, but I think we're good. So that's fine. So we're gonna say new request. What does it take? I think it's an endpoint, right? What is the endpoint? HTTP is gonna be localhost 999, if I remember correctly. Actually, it will. I think it takes a method, something like this, and then we take a body. A method is a string. That's fine. The URL, that's good. The body, it should be TX, right? And then a body, and I think the body is going to be. I think we can put the button directly. If there's an error, we're gonna panic. And then we have a request. So then we need a client. So we're going to say client is going to be HTTP default client. Not really good for using in production, by the way, default client. You should have a custom client where you can set read timeouts and write timeouts and all these good stuff. But for this, it's perfectly fine. What do we need in the default client? It's just a client. All right. What's going on? It's not a type. It's fine. Then we need to say the response. The error is going to be client do request. Again, if the error is not null, always check your errors. A lot of people hate it, but to be honest, it's a gift from heaven. It's a gift from heaven. What is going on with this default client? Why is it not working? Default client is a default client and just get... What's going on? Like this? Whoa, help. I'm confused. I'm pretty sure I use this a lot of times. Man. We're going to say printf actually. We're going to be verbose like usual. New line. And it's going to be the response, right? And then we return. We don't need to return anything. So it's probably not going to work, but that's fine. And I'm still wondering why default client is not working, but it doesn't matter. Okay, the Xender. We are already using this somewhere. Here. Yes. We can use that. Let's see what's going on. Let's see what's going on. Boom. Connection refused. It's 9,000 because remember yesterday, this is the port for HTTP JSON HTTP, by the way. So we need to adjust this real quick. 9,000 like this, and then we say make run once again and see what's going on. Okay. You can see, let's stop this. You can see this is the I think this is basically what we have on the other side in a server. Here, this is this code. It's printing it out. So that's good, right? So it's actually working. That's fine. So let's open up server here, right? And open up main on the other side. I always feel naked when I have one window open. That's why I always have two open. Then I feel warm and cozy. All right. So, wait. Yes. It's working. So we have our decoded transaction. So what are we going to do? We need to, if we open up our other server in network, And let's take a look where we handle these transactions. Let me search for it. Handle transaction. Process transaction maybe. Process trans. Let me find it manually then. Process transaction here. Boom. Nice. So what we need to do is call this function, right? So we get this transaction here, and now we need to call this function. The problem is, these are two different servers. We have our node, which is basically the server, the main server, which holds the blockchain and does gossip in the network. Then we have a JSON HTTP server, which is basically a server that handles the incoming JSON requests, APIs. So now we need to access this server, and we could actually use a channel, because embedding this server in that other server, I am not quite sure if that's a good idea, to be honest. I don't like that. So what we're gonna do, I think I'm going to make a channel specially for transactions, to be honest. So we're going to say new server. This is our API server, which is perfectly fine. So we're going to say the X channel is going to be make chan a pointer to a core transaction. I'm going to add this channel inside of this server. So we're going to say that the X channel here is going to be a chan core transaction, like this. We're going to I'm thinking, should we add it to the config or should we not add it to the config? That's a good question. It's not basically a configuration, right? A TX channel is not a type of configuration. A logger maybe, a listen address for sure, but not a TX chan. So we're gonna do it like this. It's going to be a chan core transaction like this, and then we're going to say that the TX chan is going to be that TX chan. Classic Go shenanigans. So we're going to say TX chan like this. This is a channel being used to communicate between the server, between the JSON RPC server and the node that will process this message. All right, a little bit of documentation, never hurts. Which basically means we need to have this TX chan inside of this. It's going to be a core transaction. Hey, but what? By the way, I have a better idea. Sometimes something shoots into your mind. We have this RPC channel, right? We have this RPC channel, so why don't we use that? Because let me quickly see. Wait a secundos. So why can't we say something like API Wait. I'm thinking. Server network. Server API. Too many servers. I'm not gonna lie. And it sounds like it's a rap or something. So server, instead of this TX channel, we're gonna make an RPC channel actually, which is a network RPC. And I hope I don't have circular dependencies. That would be bad. That would be so bad, not gonna lie. And the chance is high. It's gonna be a network RPC. We're gonna call this RPC channel, by the way. I hope this works. Otherwise, we need to go back to our previous thinking idea. I don't think it's is it a pointer? I don't think so. I don't think so. Okay, so the main idea is to basically do this, right? Server RPC channel, and we basically put pipe, whatever you want to call this transaction, this RPC, wait, network RPC like this, and then we say from. That's a good question. We could do something like this: C request remote address. Why not? It doesn't actually really matter, but why not? Why do not provide it? And of course, this is going to be the payload. And with a bit of chance, with a bit of luck, we can use so actually this is super neat, to be honest. So we could do something like this. Look at this. If this works, it's going to be insane. So we could say payload, and I will put the screen higher. It's maybe better for your neck and mine. Can we do this? What's going on? Invalid operation cannot call a variable of type string. And what is from? It's a net address. Okay. Can we do this? Nope. TCP address. What's inside of this thing? Oh man, this is complex. We're not gonna do this. We will fix that later on. We're gonna say, can we say nil? Yes, we can. But probably, are we reading? If we're accessing from, then we're gonna have a bad time. Then we're gonna have a bad time because from is nil. You see, we're gonna call this, right? We're gonna say RPC from. We need to fix this. C request. Do we have a connection or something? Nope. Okay, thinking real quick. How can I make a net adder? How can I make one? I see something. TCP adder from adder port. Can we do TCP net. Man, this is actually, I don't understand why we need to spend so much time on this easy thing. Net adder, what is actually this? Let me see real quick. It's an interface. The only thing we need is network and string. Interstellar. Hi, Anthony. Appreciate everything you do for the community. Love your content. Will be learning Go to follow along. Hey, much appreciated, man. Like I mentioned before in the Discord community also, these comments are worth more than any money I can wish for. Actually, I had a much better explanation. There is no money in the world that can give me this feeling. Being appreciated. That's what makes me do this stuff, right? If people like this, if people are being motivated to learn this stuff, that's the reason why I wake up, right? And it's not only crypto technology or blockchain in general. I think blockchain is just a very good point, a very good, how do I say this? A very good thing to study because it has a lot of different aspects, right? Because if you check all the series about blockchain, we basically we did transport layer, we did TCP, we are making JSON RPC, we created our own VM with bytecode. What else did we do? Gossip protocol, some crypto stuff, you know. So you learn a lot of things. What else do we need to do, right? What else do we need to do? And this port is really annoying me, and I don't know why. What I'm gonna do is this. I'm gonna say nil, and I will accept any consequences doing this. So we get this transaction. We're gonna pipe this into this RPC chain, and we're gonna hope for the best. Because this RPC chain will get this thing, and then it's gonna call this, and then our server will process it, blah, blah, it's gonna work. So, but we have some issues, I see. Some red flags. Damn it, I told you, look at this. This is probably circle dependency. Import cycle not allowed. Damn. I knew that it would happen. Why is this? It's basically because we are importing in our network package, we are importing from API. This is package API. Let me open up server, you will see. Other server. Server, network. Network, please. Yes. This is package network. And we are importing. And let me quickly see what it's exactly what we are importing. API. API.new server, right? This function, this thing. We are importing that, but we are also importing network in our API package, and that's a circular dependency, and that's prohibited in Golang. That's actually prohibited in a lot of languages, and the reason for that is because if you want to compile, the Golang compiler will be confused. Although we are 2022 and we can basically, Elon Musk is putting rockets to space, right? But we cannot do circular dependencies. That's unfortunate. But it is what it is. So what we're gonna do, this beautiful idea, I'm gonna do it in the dumpster. It was too clean, I'm not gonna lie. It would be too clean. So we're gonna refactor this. It's gonna be TX chain. I'm gonna do it real quick. TX chain, transaction channel. Transaction channel is gonna be And we need to be careful. We need to basically takes Chan is Chan core transaction. Yeah, cool. Like this. And this is not going to be an RPC channel anymore. It's going to be a core transaction like this. TX like that. Now we need to go to server, but our other servers, I know. TXChan, luckily we didn't delete this thing. That's nice. We actually, okay, we're Gucci. Where's this? Import cycle. You got to be kidding me. No, right? We need to basically RPC Chan, yeah. TX Chan here, cool. Make Chan core transaction. Okay, everybody is happy. Let me quickly do this. It's not gonna work, but I want to see. All good. So now we need to handle it. Because we are sending it to the TXChan, but now we need to read from it. So where are we going to do this? Server, of course, the network one. We are actually in it. And I think we should refactor it a little bit later on. I'm not quite sure. This is the first thing that came to mind. So we have this. What we could do is actually do this. And so this is a for select loop. It's basically a loop we spin up. Once we start up our node, this for select loop will keep running in the background, right? And in Golang, you have something like a control statement inside of this loop, which is a select, which is basically acts the same way like a normal switch select statement. And what it does is basically each time you send something to a channel, you can wait for that. Although you need to be careful, because if you are, let's say we are in this logic, in this peer channel logic, right? And somebody is sending a transaction, which we are basically going to read here, right? We're going to say it's going to be as TXChan, like this. We need to wait. We need to wait until this case statement is being processed, right? And that's the reason why we have our block loop. So we have some, what I call a validator loop, which is basically every 5 seconds, the validator is going to grab all the transactions, validate them, and put them into a block, sign the block, and broadcast the block. That's why we pulled that out into an other for select, for the reason that otherwise this 5-second block time would be inconsistent. This is very technical information, and don't worry about it unless you want to worry about it. In some of previous episodes, we mentioned this because we refactored the way the block time was working. Anyway, making things too complex now. So TX. So basically what's going to happen is, if we receive this transaction, we're going to say as server process transaction. It's going to return an error, so we're going to catch it like this. R nil We cannot return, because if we return, this loop is out of the game. So we're going to say logger log error r. We could actually say process tx error. Yes. Make run. We have no clue what's going on. Sometimes you need to be honest. I have no clue what's going on. So how can we actually make... We're going to panic here. Panic here. Sometimes panic is your best debugger, not gonna lie. Don't be afraid. It's not working. Mubashir, hello, thank you for new content. The pleasure is mine. The pleasure is mine, man. Anytime. I am waiting for programmable EVM-based blockchain. We are gonna do some Solidity soon. I have a lot of good things on the waiting list. Tomorrow, probably I will release a video, the first introduction video about quantitative trading, quant trading, whatever you want to call it. And also some Solidity stuff is coming up. But the problem is, I have a lot to do and less time. But it will. Keep holding on. Keep holding on, my friend. Hold on tight. Your content is coming very soon. So, of course it cannot work because we handle this post, but we don't do txchain, right? We don't feed it in for some reason. We forgot that. So we need to do tx and call it a day. Wait, this panic should work now. Well, the problem also is, right, is this channel ever gonna run? Damn. Am I messing something up so hard? Let us do something. We're gonna say go func like this for tx is going to be txchain like this. Printf verbose new line tx. Actually, make it It's probably some stupid mistake, like it always is, right? We still get it, right? We still get it here. Yes, that's working. Okay, cool. So we do this transaction channel. That's good. So what's going on? So we make this channel. We make this transaction channel. If I'm not wrong, quant trading is mostly market making and arbitrage strategies, right, mentor? Yes, that's right. That's exactly true. Well, quant trading has a lot of, it depends. If you want to be precise, quant trading has a lot of different aspects. For example, high frequency trading could also considered being quant trading or not. Maybe it has a separate thing. But if you want to say that everything that's programmatically trading is quant trading, then you have high frequency trading, market making. You have market making with arbitrage. You have some people using like these simple algorithms. For example, they use a 20 moving average or a 200 moving average, and they just check if the price is above, they buy, they long. If the price is below, they short. But I don't think that's trash, in my opinion. And every YouTube video about my algorithm made $250 a day is basically a tutorial with moving averages. I don't understand. But the thing is, people like these videos, right? Because I always say in the, what's the sentence? It's, in the land of the blind, the one-eyed man is king. And that's exactly what's happening in the trading scene, right? Let that sink in, right? Let that sink in. But we're going to change this. We are going to change this. We're going to mostly focus on market making algorithms and especially on arbitrage. Why? Because arbitrage is, in my opinion, the only way you can have a consistent, risk-free, deterministic way of making your algorithm work. And all the rest is bullshit. Every other algorithm doesn't work. It just don't. It just don't. They're all scam. Yeah, it is. They're all scam. I mean, of course, if you're lucky, especially in bull markets, or even especially when the market is moving a lot, like if you do this the last month, you're gonna get wrecked. But if you do this in trending markets, depending whether the site, your algorithms, these scam algorithms working with these MAs, moving averages, will make some money for a short period of time, right? But that doesn't matter. You need to pull your algorithm over 2 years or over 1 year, and they will get wrecked. It's done, right? That's the reason why day trading, it just doesn't work. It just doesn't work, man. I don't understand. But anyway, enough. Even the FX market works on liquidity model you mentioned. Yes. Yes, the thing is, a trading market, trading, like even if it's Forex, stocks, cryptocurrency, it's all the same. It works exactly the same as your supermarket where you buy your apples. It's exactly the same, right? These guys, they buy apples for $10. They put these apples in a basket in the storefront. I'm beating up my microphone. In the storefront. So you can buy these apples for $12 and they make $2, right? That's the spread. That's how it works. And who is making the price? You are making the price. Because look, the world, it's all about arbitrage, right? The world is rigged to come to equilibrium, to come to fair value. That's what markets always do, and that is what markets always will do. Come to fair value. And who is determining that price? You. We are determining that price. Because if you have 3 supermarkets and they all selling apples, but one is selling apples for $10, the other one is selling apples for $50, and then some other market is in between for $25, for example. Where are you going to buy your apples? At the cheapest one, right? So what are the other markets going to do? They see, what the fuck, nobody's coming to our store. My apples are getting rotten. So they're going to lower the price, right? And then when they lower the price, people are going to that store because they are cheaper than they were before, right? So the market with the cheap apples see, oh, people are actually buying apples for more than $10. I will move my price up, right? Fair value. You are the guy. You are the thing. We the people. And it works with everything. It works in every single asset. It works in sports teams, the same thing. In soccer teams, right? Soccer teams, the same thing. Football, whatever. Arbitrage. Bad players get switched by good players, so they will make the competition standing will be higher, right? Of course, eventually, the team with the most capital can buy the best players, so they will be at number 1. If that makes sense. Man, we are actually getting out of track. I hope that makes sense. Somebody clip this stuff. Clip it and post it. Because that's the real truth. Nobody is telling about it because they want to sell you something. That's the thing. They're willing to sell you something, and I'm thirsty. So you say that Trader B on Twitter is not right? Yes, that's what I'm telling. They're a piece of shit. Have no idea what they're talking about. All right, let's get back to business, right? And now I'm totally out of track. Great explanation as usual. It's okay. I have my own way of explaining things. I'm not the best communicator. I know, but I try my best. Sometimes I'm actually re-watch my own streams. Not because I'm a narcissist or something, but just because I want to see if everything went well and and then I see myself talk. I said, "Oh my God, what the hell are you doing?" Okay. So this channel, right? This channel. We have this transaction channel. We make it here. We put that thing inside of this API server. That's perfectly fine. And then look at this. Look at this. This is not correct. TXchen. We are making a new one. Of course, nobody is sending to the new boy, right? All right, let's see. Nice. It's working. You see this? So here. So we're gonna delete this thingy and hope it worked here. Boom, boom, boom. Yes. How can we know that it's working? Well, I don't know. Yes, it worked because we have one transaction here, right? It's working. it is working. So how can we test this? How can I show you better, by the way? So we're gonna get the first block. We can see there is a transaction. And we're gonna, how do I copy? What the hell is this? Look at this, there is no way to copy. Well, transaction, and then we paste in. Look at this, man. Windows. Man, this does not make any sense. Control C. Yes, thank you. All right, so this is basically this transaction. How can we make this more explicit? We're gonna keep sending transactions. That's what we're gonna do. Main. So we don't care. The response, we don't care about the response. We don't care about the response, guys, girls. Yes. OBS, yep. We're gonna make a loop. We're gonna say TX sender. We're gonna make a for loop. We're gonna make a go routine. Actually, we're gonna make a go routine above. Go func. This, hop. Time.sleep. It's actually, I made a YouTube short yesterday where I told the world that you should not use time sleep in for loops. And now I'm gonna do it. That would be BS, I'm not gonna lie. So what you can do is basically make a ticker somewhere. TX ticker. TX send ticker. It's gonna be a time new ticker. We say every second because we're madmen. Time second, like this. And then instead of saying time sleep, we wait for the channel of the TX send ticker C. If you call C, it will return a channel which you can wait for. And why is it better than sleep? Because if you sleep, if you use that, it will eat up your CPU a lot. Insane. So don't do that. Especially not if you need to sleep for a very long time, or you need to call it a lot. And you can, if you use a ticker, you can have more control. You could, I don't know what you can do with this ticker. Let me see. You can reset and stop it. So you have more control. So it was no lie. You have more control. You also have something like time.interval or something. Time new no. Leave it. But I know there is something like an interval that does the same thing. Kinda. Yeah. So we have this ticker. So basically what happens every second, we're gonna read this channel, it's gonna loop and blah blah blah. We're gonna send this transaction, okay? The problem is that it's going to send the same transaction with the same bytes, the same smart contracts inside of it. Well, smart contract. Quote, quote, because it's our own bytecode, but it's going to hash to the same transaction, to the same hash. Why? Because we forgot actually to do something, and I will show you, because this is actually very valuable, what I'm going to teach you, show you. So let us first boot this up, right? Let's see if this transaction is coming in. So I'm going to say make run. So we have one transaction, that's fine. I'm confused. You see what's going, yeah, I know exactly what's going on. So normally what should happen is each block we should have a transaction because we're posting every 1 second. But the problem is, like I mentioned, this transaction if we hash it, all these transactions will hash to the same hash because it's the same address, it's the same data, it's the same everything. So how can we fix this? Well, the most of those platforms, they use something what is called a nonce. And what is a nonce? That's something I don't understand his name, to be honest. A nonce is basically, if I told you that you are a nonce, which basically means you're a piece of shit, but that's not true. A nonce is something random. So how are we gonna do this? We're gonna open up transaction real quick. Please add smart contract support in this blockchain. I will. We have actually, but you need to, but no EVM. No EVM. And to be honest, if you really want to do EVM stuff, there is something that's called Ganache, right? The Ganache truffle suite. It's easy to set up. We use that actually in our crypto exchange in Golang, where we're creating a complete exchange tied to a private blockchain. And you can actually just write your contracts and execute it on that very easily. You have infinite amount of currency. It's basically doing blockchain on cheats. UK, Jared, nonce mean idiot in UK, exactly. That's true. It means idiot, nothing, yeah. It is. But in this case, it could be that this is being called nonce because it's actually useless. But very useful, to be honest. I don't know. Let's stop this talking. So what we're gonna do is we're gonna make a nonce. It's gonna be, it should be a UN64, to be honest. So if we call new transaction, we are gonna say that the nonce is going to be a rand int. Mubashi, no, I want to create own virtual machine for own blockchain. That's the right spirit, because that's how you're gonna learn a lot of things. Well, we will have an episode where we will dive deeper into our virtual machine, where we're gonna make it expanded a little bit more, because that's one of my favorite things, is compiler technology, and virtual machines is something I'm really interested in. I love to do that stuff. And maybe actually the dream would be that we embed the Ethereum virtual machine inside of this blockchain. Can you imagine? It's going to be a lot of work though. But I think there are standalone EVM-based virtual machines, and basically the client of Ethereum is being written in Go, so we could just yoink. Whatever, we will see what we're going to do with it. So the nonce is going to be rand int n. We're going to make this a large number. We're going to say it's a uint. Actually, what does it return, rand int n? An int. Doesn't matter. Let's see. Come on. Why? Okay, I know the problem. We are not hashing it. Damn. So we are basically, the only thing we hash is the data. So there's nonce, it's there, but it won't be hashed. Roshan Swain, can you give a blockchain 101 important parts you are building in this blockchain? Yes. So a blockchain is basically nothing more than a distributed database, a decentralized distributed database, right? So what do you need in a distributed database? You need a transport layer. You need to have a way to transport messages. So that could be a TCP, a UDP. So that's a very important aspect, is your transport. You also need a way to communicate, some kind of a protocol. That's what they call a gossip protocol. So you need to have a lot of encoding and decoding messages. That's an important aspect. You also need a way to come to consensus, because if you have a distributed network of nodes, a distributed network of random nodes, how do you know who can you trust? Who is speaking the truth? Who is lying to you? You don't know. You don't know. And it's a very important lesson in life. You cannot trust anybody. So, especially not in blockchain. So you need to have a consensus. So you need to make a consensus algorithm. That's an important part. You need to have a way to communicate with your blockchain from the outside, right? People need to have a way to retrieve information. People need to have a way to actually interact with your blockchain so it can store or execute code, which is the JSON, which is an API server, an RPC, a JSON RPC, whatever RPC you want to call it. That's an important aspect. You need to have, I'm trying to make it as high level as possible, right? It's of course more complicated than that, but you need to have a virtual machine, especially if you want to make decentralized applications, right? A virtual machine, something that can execute code. You need to have your database, because it's a distributed database, a decentralized distributed database. So you need to have your database. You need to write your database, or you use an existing key value store. It's all up to you. These things. And if you open up this folder, we can see we have the network layer, right? We have TX pool, transportation, messages, RPC, encoding. We have our crypto, we have key pairs, private key, private keys, public keys, cryptography, important, core, blocks. We have our blockchain. It's a very important module. What parts are we building in this project? Every single part. This is an educational, this blockchain is not to replace something or to be better than something else or to prove a point. This blockchain is because I want to show people how it works internally. Is it the best code? Is this the most performant code? Probably not. But this is a reflection of reality, right? I'm pretty sure there are blockchains out there that have worse code than this. So it's going to be a complete working blockchain. Everything, every single layer will be inside of this, which will eventually be just a normal blockchain, but we're not going to make it in production. It's an educational thing. Because I think it's important if you want to have a career in Web3 or blockchain or whatever, which will be a big part of the future. There is no doubt about it, right? We don't know how it's going to be, but decentralization is something that's going to be very important because people are realizing more and more that is a big thing. So if you really want to know how these things work, even though you have no intentions to be a core blockchain developer, but if you know how it works, you know the limitations, because a lot of people are complaining, yeah, but blockchain is so slow and these transactions, it takes so long and my transaction is stuck. Why is my transaction stuck? They have no clue. But if you know what's going on behind the scenes, you can place everything in context, right? You can place everything in context. Oh, my transaction is stuck. Yeah, that's because you do not attach a lot of gas to it, so it keeps sitting somewhere and people are making new transactions with more gas fees, so they get prioritized and you're sitting on the bottom, for example, right? So that's important. And you will learn a lot of aspects, right? You will learn how to write a virtual machine. Also, although it's basic, but you will learn it, right? You will learn the basics. You don't need to be a specialist, right? That's the reason. I hope that answered your question. Okay, this problem, transactions. So what we're gonna do, actually, we're gonna cheat a little bit. Actually, it's not cheating, but instead of, wait. Give me a moment. Where is hash? Here. Hasher, hash. Boom. B bytes. That's the head. The takes data. Transaction. I'm going to do a little cheat. I'm going to say a buffer is going to be make a slice of bytes 8. Why? Because we're going to put the nonce. We're going to put the nonce inside of it. And a uint, actually an N64 is 8 bytes. N32 is 4 bytes. A uint 8 is 1 byte. A uint is also 1 byte. Is also 4 bytes. Basics. A pointer is also 8 bytes. Yeah, this buffer. So what we're gonna do is we're gonna say binary write how does it work? Binary write little endian. Can we do this? Probably not. No, it's not this. It's binary, right? Help. Put uint 64. And what does it take? It takes a byte and a uint. Okay, I see. So it takes this buffer and we're gonna say it's a tx nonce. Why is it not working? Okay, I see. We're gonna still not working. Cannot use. Oh, I see. Okay. Data is going to be append buff takes data. I don't know what I'm doing. This could work, but also not. So we're gonna SHA the whole shebang. And I will explain what we're doing. I will explain in a minute. Transactions 4, you see it's working. Yes. So, and then it's clear. So basically what happens, we are posting transactions, boom, boom, boom. each every 1 second, but we have a block time of 5. So calculating a little bit of delay, we have 4 transactions in one block. That's what's happening. Even 5 sometimes, you see. Actually, it should be 5, to be honest. It should be 5, right? Because we have a block time of 5, and we're posting 1 transaction a second. So sometimes it would be 5, and sometimes it would be 4, because, yeah, of course, you have some delay, and it's working. That is amazing. So let us basically do something like, stop, please. New block. This is the hash. Let's open up this. Let's do block. Paste this in. We see 4 transactions. These are the transactions. Copy. TX. Boom. Yes. Nonce. We even have a nonce. Can you imagine? So it's working. So what did I do? Well, so what did I do? So basically, if we hash a transaction, the only thing we do is hash the data. But the problem is, if I post a transaction, if 2 people make the same contract, and we post a transaction, it will hash to the same hash, even though it's different. And actually, we need to rework this. So I'm going to do a little bit of research, because how are we going to do this better? So instead of only hashing the data, this is the arbitrary code, arbitrary bytecode, I'm also writing a uint into a byte, and then appending the bytes, and then hash all the shenanigans, all the shebang, and that should give us a random hash. And if people want to recalculate the hash, well, they can, because they have the nonce, they have the bytecode. The only thing they need to do is append these 2 together, hash it, and it's done. It works for now. It works for now. Cool. Dropped frames, 230. So, and basically YouTube is telling me that between 12 and 2 are the best times to stream. What do you think? I don't know, when are people are on YouTube? When do you watch YouTube? What's your favorite time to watch some YouTube videos? I'm so curious. I'm doing a little bit of market research. A little bit of a market research. Okay, so it's all working fine. It's been on a time zone. Yeah, it is. It is. I'm goofing up while working now. Swain. Anytime you're alive. That's the best answer. That's what I want to hear. That's what I want to hear. Anytime you're alive. Can you see the... No, I cannot see anything, Gerard. I'm still new. I'm still actually new to all this YouTube stuff, right? So... I don't know. Because I was thinking the best times would be in the evening, right? Between, I don't know, 8 and midnight. Something like that. That's also when I'm the most, you know? My voice is completely warmed up. My muscle memory is on point. But I thought I'm going to stream between 12 and 2 because YouTube recommend me, but I don't believe it. All right, so this transaction is working. That's nice. Let me quickly check. Yes, that's fine. Yeah, I think I planned this task at hand for today, and look at this. We are in a good spot. Let me quickly see if testing actually works. Probably not. It is. That's fine. That's fine. So what we could test is it's executing this code. That's good. One more thing we can actually do is we don't have. It's my office time now. You're getting paid. You're getting paid to watch, which is good. I wish I was you. What we don't store is basically users. So there is no way, there is no API to retrieve, for example, an address. So people are posting these transactions. If we want to know, if we want to look up an address, for example, to check, I don't know, how many transactions they've done, maybe a currency or something, right? We can't. So that's something we can implement. The question rather is, wait, let me quickly check. Yes. Any resources you would recommend for learning Golang? Yes, here. That's this question. No, good resources. I actually don't know. I don't know. I know you would learn a lot from my videos, but they are not really Golang tutorials pure sang. But I don't know. Actually, Go is a very simple language. What kind of languages do you write? What kind of languages do you know already? I think if you know C or Python, or if you know any type of language, any programming language, Go is very easy to pick up. It's very easy. The basics. Go by example. Well, I don't know. I don't know his channel, but it could be probably. Probably. Actually, the Go. Wait, let me quickly. Let me do something real quick. So you have something like Go Playground, or what is it? Wait, there was something like Go by example. Yeah, man, go by example. That's it. That's what I was looking for. Look at this. Look at this. So how can I go back? So easy. Look at this. Hello world, values, variables, constants, for, if, else, switch, array, slices, maps, range, function, multiple alternatives, validate, function, closures, recursion, everything, the whole shebang. Amazing. Generics. Yeah. Let me see. Pointers, that's always important. Let me see how they do this. Oh my God. This is the worst example there is. This is literally trash. Literally trash. Look at this. But it is what it is. Channel buffering, yeah. Rate limiting, why should you? But I think if you follow these, so if you, wait, let me check what, yes, Python. So the only thing you need to do is look up, right? Programming is in every single language is the same. It's the same. It's the solution you want to solve. It's just a different tool. So if you know you want to use a for loop, for example, if you're going to use a switch statement, the only thing you need to do is look up the syntax, right? And Go is very minimalistic. It's also very easy to write. Of course, if you're going to work with these channels and synchronization and Go routines, that can be a little bit tricky. But I think if you try something out, trial and error, just go put your editor open, make some projects, spin up some Go routines and check how it works. It won't take you too long to learn. It won't. Okie dokie. So I think I'm gonna close the stream for now. I'm not sure if I'm going to stream tonight because I'm going to prepare the quantitative trading shenanigans. But I'm not sure if I will stream. You will join the Discord, ring the notifications bell so you're always subscribed to my channel, of course, so you'll always be notified. Are there any more questions? Happy to resolve. Any question? Ask me anything. Did we actually? And I adjusted the Discord link, so if you want to join the community, the link of the Discord will be in the description. Let me quickly test this. Yes, should be working. That's good. All right, cool. Everything is Gucci. Thank you for everything. The pleasure is mine. The pleasure is mine. Design a microservice in Golang. Yes, but to be honest, design a microservice in Golang. That's basically what we do, right? Because every single thing is, if you could call this a microservice, right? If you take our API server, for example, it's basically just a simple, where is it? New server. It's just this, right? It's a simple HTTP server with some handlers, and we spin it up. So what is this? It's basically a microservice. It's a microservice. It runs on its own port. The only thing we do is boot that up alongside with the other node. And if you want to write microservices, I would recommend you to use GoKit. GoKit, that's an insane package. GoKit, let me quickly check. Yes. This one. GoKit. GoKit is a programming toolkit for building microservices or elegant monoliths in Go. We solve common problems in a distributed systems and application architecture so you can focus on delivering business value. It's insane. It's a very good thing. Not quite sure if it's still being maintained. It probably is. 6 years ago, holy crap. 2 months ago. The only thing they did was basically update it to Go 1.19. Hard to say. All right, guys, I would say, and girls, and maybe Gorilla. Yes, Gorilla, I know, but Gorilla is old school. It's good for what it was. It's too big of a thing. Don't use it. Do not use it anymore. Times changed. All right, thanks everyone for watching, and I see you in one of my next videos or live streams. Have a nice day, and don't forget to stretch your back or go to the gym so you can keep your testosterone levels at a good point. Cheers.